All right, so let's begin with circles. Circles are probably the simplest of the conic sections, and they provide us a nice familiar place to start. So remember that the definition of a circle is the set of all points that are exactly a fixed distance away from some central point. So let's say this is my two-dimensional flat Cartesian coordinate plane. I don't know where the x and the y axes are. It doesn't really matter. They could be somewhere else. They could be somewhere in the middle. I don't know, whatever. Here's my plane. I'm going to pick a point to be my central point. So that I'm going to label it center, and I'm going to give its coordinates the values h and k. Okay, hk. That's my center. So now what I want to do is choose a radius. I've chosen a center, and now I'll choose a radius. So my radius is the distance that I'm going to work with. So let's say it's that. I'll label that r and put a little label radius on it. So now any point which is exactly that distance away from my center is going to be on the curve. So for example, this point here, right here, will be on the curve. And if I take that distance and I reproduce it somewhere else, like over here, there's approximately the same distance. I'll have another point on the curve, and over here, boop, there's a point on the curve. I'm just kind of estimating that distance. There'll be a point on the curve. And any point that is exactly that distance away will be on the curve, which means there's going to be infinitely many points, right? They're going to look something like this. Let's see how good of a circle I can draw. Not terribly good. All right. I'm kind of embarrassed by how bad that circle is, but that's okay. It's decent. So I've got my central point here, and then there's all the points on the circle. All the points distance r away from the center. So what we want to do is come up with an equation for this curve. And an equation is going to have two variables, x and y. And we want it to be such that the solutions to that equation, meaning the x and y values that satisfy it, are points on the curve, right? That's what the graph of an equation is. It's the set of all solution points, right? So I'm going to have x and y. The variables that I want to use for my equation represent the coordinates of points on the circle. Okay, I'm just going to call. I'm going to basically pick an arbitrary point, which could be any point on the circle, and call it xy. That could be anywhere. Think of this as like a variable point that can move around. Center is fixed, radius is fixed, but this guy can be anywhere. So now what I want to do is say the distance from the center, hk, to the point xy, that distance between those 2 points has to equal r. That's my goal, right? Well, to do this, all I need to do is remember what the distance formula is. The distance formula that comes from the Pythagorean theorem. We learned this back in the review in the first week. So the distance formula, you may remember, is given by a big square root, where what we're going to do is take the difference in the x coordinates, so like x minus h, I'm going to do it in that order, x minus h, and square that. And then add that to the difference in the y coordinates, which will be y minus k, and square that. And this has to equal r. So there we go. So that's an equation for the circle. I'm pretty much done. The only thing I might want to do here is simplify this up a little bit. I can square both sides, pow, pow, and get something a little nicer to look at. X minus h squared plus y minus k squared equals r squared. And traditionally, that is the equation we use for a circle. Without this big square root over the top, it just makes it a little cleaner and easier to look at. But it's important to remember that without that big square root, the constant you're looking at over on the right-hand side, or whichever side you put it, that constant is the square of the radius, not the radius itself. So let's run through a quick example. If you look at the equation x minus 2 squared plus quantity y plus 3 squared equals 4, like that, then we can get from this equation all the useful information we need to graph the circle. For example, like I said, that constant over there is the square of the radius, so that means that 4 is r squared, so r is 2. The radius of that circle will be 2. The other thing you can do is look at what numbers are being subtracted from x and y. Remember that those are the coordinates of the center point. So here we see 2 is subtracted from x. That would be the h value. H is the x coordinate of the center point. So my center point is going to have x coordinate 2. And then and then the number that's subtracted from y is going to be the k, which will be the y coordinate of the center point. Here we have y plus 3, but remember that y plus 3 can be interpreted as y minus negative 3. The minus negative becomes plus, right? So we normally wouldn't write minus negative, but if you think about it that way, the number that's being subtracted from y, the k value in this case, is negative 3. So there we go. We got radius of 2 and center of 2, negative 3. And now all we need to do to graph this circle is make ourselves a little coordinate plane. Let's put some measurement on here. Put some tick marks. There we go. So now we want to find the center, 2, negative 3. On the x-axis we go 2. On the y-axis we'll go down 3. 1, 2, 3. So there's our center. Like that, right? And now, to draw the circle, we're going to find points that are exactly 2 units away from that. I like to go vertically and horizontally, so I'm going to go up 2 points from here and put a point right there. I'm going to go down 2 units and put a point right there. I'm going to go left 2 units, and I'm going to go right 2 units. So there's from the center point measuring out 2 units in all directions, and then I can draw my nice circle. This circle hopefully should be pretty decent. Not bad. There's my circle. So I started with an equation, and from the equation I found the graph. If you start with this graph, it is pretty equally easy to go back and figure out what the equation is just by identifying what are the coordinates at the center. Use those for h and k, and what is the distance? What is the radius here? Use that for r, and you can get an equation. A lot of what we're going to be doing with conic sections, not just circles, but others as well, is kind of translating back and forth between equation and graph.